Method updatePositions is called by our canon thread repeatedly to update the positions of all the different game elements on the screen. Now, you notice that this method receives as its argument a double indicating the elapsed time in milliseconds, and basically this is the time between, if you will, animation frames. So basically we have these different elements that are moving around on the screen, and in between the last time that updatePositions was called and this time that updatePositions was called, a certain amount of time in milliseconds has elapsed, and we want to then update the positions of all of the elements on the screen based on that time. Now, rather than using a fixed amount of time in between animation frames, we try to draw the screen as fast as we can and then simply scale the positions of everything based on how much time has elapsed. And this accounts or helps account for variable frame rates, basically because your device, depending on the speed of its processor, may not be able to refresh the screen as fast as my device might be able to, or vice versa. And separately, when you have lots of different things running, it's conceivable that at any given time on the device there could be a longer or shorter distance between animation frames. So in order to account for all of that, rather than scaling everything a fixed amount every single time updatePositions gets called, we scale based on the elapsed time in milliseconds. So the first thing we do is determine what the interval was in seconds by dividing that argument by 1000. And then if there's a cannonball on the screen, we do a bunch of testing to determine if the cannonball is colliding with anything. So first we update the cannonball's position by multiplying the interval times the cannonball's velocity in the x and y directions, and we update the cannonball's x and y position based on that. And then we do our collision detection with the blocker, and if in fact we have a collision with the blocker, we reverse the cannonball's x velocity to make it bounce back. We subtract the miss penalty from the time left, and we play the sound that represents the ball colliding with the blocker. On the other hand, if we had a collision with the left or right wall, we would want to remove the cannonball from the screen. So in that case, we simply set cannonball on screen to false. Same thing if we collide with the top and bottom of the screen, or top or bottom, I should say, of the screen. If the cannonball collides with a target, then we have to figure out which piece of the target it collided with. So we do a calculation to determine which section we collided with. Then we check to see if that section is greater than or equal to 0 and less than the number of pieces. And if it is, and also that section has not been hit previously, then we say that the section was hit. We remove the cannonball from the screen. We add the hit reward, saying that you now get a bonus in your time remaining because you hit a target piece. We play the hit sound for hitting the target. And then if the number of target pieces hit after incrementing it is equal to the total number of target pieces, we know we've finished the game, at which point we stop the thread from running by calling its setRunning method and setting it to false. We show the game over dialog with the win string, and we set game over to true to indicate that the game is over. After we do all of the hit testing, we also go ahead and update the various game elements. So for the blocker, we determine the amount to update the blocker by, and then we add that to the y coordinates of both the start and end points of the blocker. Same issue for the target as well. And then if the blocker has hit the top or bottom of the screen, we reverse its direction by multiplying its velocity by -1. Same thing for the target. And we subtract the interval from the time left to indicate that there's less time left in the game. If the time left is less than or equal to 0, then we set the time left to 0 because we don't want to display a negative number for time left on the screen. We set game over to true because the user has not finished the game before running out of time, so the game ends and the user loses. We set running on the cannon thread to false, and we display the game over dialog with the lose string as its message in this case.